welcome back to my YouTube channel. So today we are going to solve day 12 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2654. Minimum number of operations to make all array elements equal to 1. So in this problem you are given a 0 indexed array nums consisting of positive integers. You can do the following operation on the array any number of times. We have to select an index I such that I should be greater than equal to 0 and less than n minus 1, and we have to replace either of nums of I or nums of I plus 1 with their GCD value, right? And we have to return the minimum number of operations to make all elements of nums equal to 1. If it is impossible, then in that case we have to return minus 1. And the GCD of two integers is the greatest common divisor of the two integers, right? So let's say if you want to calculate GCD of 10 and 15, so the output is going to be 5, right? Because 10 is divisible by 5 completely and 15 is also divisible by 5, right? And this 5 is the max number which divides both, right? Same way, if I ask you to calculate GCD of 7 and 3, then the output is going to be 1 only, right? There is no other number than 1 who divides both the number completely, right? So that's what we need to do, right? Now see here, this example number 1. This is my nums array, right? So we have to just make all the elements equal to 1 in the end, right? So what is the length of this nums array? Length of nums array is 4. And tell me, is there any number of ones in this array or not? So no, there are no ones. So we have to make one number first, right? Make a number equal to 1 first, right? So you have many ways to make a number 4, right? So if you just pick this subarray, right, 3 comma 4, then you will find out that you can make any number, right? If you do the GCD of these two, you will get 1, right? So here let's suppose this is your index 1 index 2 index 3 index. Okay, so let's suppose you choose index I is equal to 2, right? And then you can replace this nums of 2 with the GCD of 3 comma 4, right? So GCD of 3 comma 4 we are taking, right? Because here we have to select an index I and replace either of nums of I or nums of I plus 1 with their GCD value, I and I plus 1, the value at I and I plus 1 index. So we have to replace with the GCD value, right? So let's suppose if I choose index I is equal to 2, then I can replace nums of 2 with GCD of 3 comma 4, that is equal to 1, right? So now we have this 2614. So once I have a 1 in my nums array, then after that it is going to be very easy, right? Then after that, let's suppose if I choose this now, so this neighboring element is 1, so definitely I will get GCD equal to 1, right? So that is done. So this is going to become 1. Now if this is 1, then I can choose this, right? Choose index I is equal to 0 and replace nums of 0 with GCD of 2 comma 1, that is also done. And let's suppose in the end 0 1 2 3, so again you choose index I is equal to 2, right? Here also you are choosing I is equal to 2, here also you are choosing I is equal to 2. Again you replace, this time you are replacing nums of 3, here you are replacing nums of 2, right? So it is given that we have to select an index I, right, and replace either of nums of I or nums of I plus 1 with their GCD value, right? We can replace either nums of I element or nums of I plus 1 element, right, with the GCD value of it, GCD value of this nums of I and nums of I plus 1, right? So here again we are replacing 1, right? So initially there are no ones, right? So first thing that we need to do, we have to make the 1, we have to add somehow 1, right? Right, so we have to do some operation for that. But once we get any one right, then in that case it is very easy, right? So here 2614 we get, right? And in the end, what is the total length? Total length is 4, and now remaining elements 1 2 3. So uh, number of ones is 1, right? So 4 minus 1 is equal to 3. 3 is nothing but remaining elements, so 3 more operations, right? This is one operation and 3 more after that for these 3 numbers, right? So 3 plus 1 4 is the output, right? See this example number 2. right? 2, 10, 6, 14. So we will never get GCD equal to 1 in this case, right? So here, if you do this 2, 10, if you take this, so what is the GCD of this? 2, right? So you can replace any with 2, right? So let's say you do this. Now, after that, here, if you pick this, right, 2, 2. So here again, what is the GCD you are going to get of 2, 2? So GCD of 2, 2 is nothing but you will get 2 only again, right? So you will never get actually 1, right? It can be shown that it is impossible to make all the elements equal to 1, right? Clear? Okay, so this is how you write na? 2 and again 2. So 2 is the greatest common divisor, right, for both, right? So again you are going to get 2 only. Same way here also, I think 2, 6, you are going to get 2 only. That's how you change it. Again here also you are going to get 2 only, right? And you will never get. Okay, so that's it. So these are the constants. Constant size is small. Nums dot length from 2 to 50 and nums of I value from 1 to 10 to 6, right? Let's take this example. Let's take this example. 2, 4, 5, 1, 6, 8, 9, something like this. So here in this case, see, one is available, right? So what is the total length? 1, 2, 3, 4, 5, 6, 7. So total length is 7, right? And number of ones is 1, right? So remaining elements is 1, 2, 3, 4, 5, 6. So definitely how many number of operations I need to do here? N minus number of ones, that is nothing but number of ones, that is nothing but 7 minus 1, that is now 6. 6 is the number of operations, so we can directly return our output 6 if anyone is available, right? If anyone is available. Same way here, 2, 1, 2, 1. In this case, so length is 4 minus number of ones 2, so 2 number of operations we need to do. Simply we can return the output. But if 1 is not available, right, then we have to do some operation, some number of operations to get first one. So in this case, only one operation we did for 3, 4, right? But if you see this example, right, 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, right? So first, let's suppose you are here. So 6 and 10, you calculate the GCD of 6 and 10. You are going to get what? You are going to get 2, right? GCD of 6, 10, right? Then after that, let's suppose this is for just 6 and 10. Let's suppose you take this 6, 10 and 15, this subarray. So in this subarray, GCD of 6 and 10 is 2, and with 15 if you do, you are going to get 1. So now you are going to get 1, right? Now you are going to get 1. So here number of operations you are doing is 2 initially. Can we have one number operation to get 1? You can try different possibilities. So if I'm starting from here, then if I take this complete subarray, only then I'm going to get very first one, right? Okay, let's say I want to start from here, right? So GCD of 10 and next element is 15. So 10 and 15 is 5. Okay, again GCD is not equal to 1. Next time this is for 10 comma 15. Next time 10 comma 15, next element it's a 3. So GCD of 10, 15 is 5 and 3. Now we are going to get 1, right? Again number of operations is equal to 2, right? So from 10 if I'm starting now, so this is a subarray in that I'm using to get the very first one, right? 1 is not there initially, right? So this is very first. Okay, this is done. Now 15 and 3, so I will get 3. 3 and 9, I will get 3, right? And 3 and 18, again I will get 3. So I'm not getting 1 anywhere, right? Now after that, if I start from 3, let's say 3, then 3 9, no, then I will get 3, 3 18, I will again get 3 only. That's it. Again if I start from here 9, 9 18, I will get what I will get? I will get 9, right? That's it. So see, only if I use this subarray or this subarray, right? So what I'm doing, I'm placing my I here, then I'm checking J here, and as soon as I get my GCD1, so I am ending this, right? So what is the length of this? So length of this is nothing but 3, right? What is the length of this subarray? The length of this one is 3, right? So if I do, if you notice here, if I do length minus 1 here, so I'm getting but 2 here. Same way, if I do length minus 1, I am getting 2 here, and 2 is nothing but the number of operations I'm doing here. So GCD of 6 and 10, so I will get 2, right? So let's say I'm replacing 2 here, then 2 and 15 I'm doing GCD, so I'm getting 1. So let's say I'm replacing 1 here. So this is how I'm getting very first one, right? Clear? Same way here, if you take 10 and 50, let's say, so 10 and 50 you are going to get GCD 5. So let's say you replace 5 here, then 5 and 10 you get GCD 1. Let's say you replace 1 here. So this is how you are getting very first one, right? So here, if you notice, length minus 1, length is nothing but the size of subarray, right, which we can easily calculate. And if you do length minus 1, you will get the number of operations, right? Done. So if you do this length of minus 1, you will get the number of operations to get the very first one if it is not possible, right? In this you have to add what? You have to add the remaining length. So remaining length is nothing but n 1 2 3 4 5 6, right? n, and here minus 1 5, that's it. So you are going to get 2 plus 5, that is nothing but 7 as the output. That's it. So now let's write the code for this, right? So same story, whatever I have explained, I'm going to do the same thing in the code, right? So first thing here, let's just calculate the length of your nums array, nums dot length, and we have to count the number of ones. So initially the count is 0. Then here you have to just iterate over all the elements in your num array one by one. So you can use this enhanced for loop, and here just check if num is equal to 1. In that case, ones plus plus, right? And now case 1, that if you already has 1, right? So if ones is greater than 0, then you have to simply return the output as n minus ones. That's it. And what is your step 2? Step 2 is nothing but to find the smallest subarray with GCD is equal to 1, right? So let's say min length is equal to integer dot max underscore value, right? And then inside this just run one loop, int I is equal to 0, I is less than n, and here I plus plus, and here int g is nothing but nums of I. First index I fixed it, and then I'm inside it, I'm just going to run j loop, int j is equal to I plus 1, j is less than n, and j plus plus, right? So here I'm updating my g as nothing but GCD of g, and here nums of j, right? This is how I'm updating g. And as soon as my this g value is going to become 1, that simply means I'm going to get the first subarray in which if I do the GCD, right, I will get 1 for very first time, right? So here I will just update the min length. What is the min length that I'm getting here? So here I'm updating math.min of min length, comma, here j minus I plus 1, that is nothing but the total length, right, of the current window, and we will break it. Now after that I will start my I from next index, right? So from that position I will find a subarray, then from next I will find the subarray, right? In this way I will just find the mean length in the end, right? So this is my next step, right? This is my current step, and after that if no subarray found, right? So here if my mean length is still equal to integer dot max value, right? So in that case we have to simply return what? We have to return -1, right? This is done. Clear? Now after this, in the end we have to just return the total number of operations. Total number of operations is nothing but first mean length -1. This I have already explained, right? So this is to get the very first subarray, very first number of operations that we are doing in current subarray to get first one, right? And then remaining elements is nothing but n minus 1. That's it. Clear? This is done. Okay, so this is what I was doing here, right? To get output as 7 in the end, right? And that's it. Now this is done. Now GCD, how we are going to calculate this GCD? So this is very easy, right? We have solved many questions using this Euclidean algorithm, right, to calculate the GCD. So here, let's suppose I have int a and int b. So what we do, if my b is not equal to 0, if b is not equal to 0, then in that case what we do, we just return what, we just return GCD of, and here this my a is going to become b and my b is going to become a modulus with b, right? This is how we used to do this using recursive approach, right? And in the end we just return a, right? Return a. So we have solved many questions, around 10 to 20 with this logic GCD. This is how we calculate, right? So you can practice, you can give any two numbers like 5 and 10 and then just practice this. Give 2 and 7, just practice this, right? That's it. So now let's run the code. Okay, so here what we are getting, okay, minus sign I'm using, right? This should be equal to, let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.